Welcome to Shree Learning Academy. Our today's topic is Traceroute. So let's get started. As you journey through the world of computers and networks, you may come across the term Tracert or Traceroute. And if this term is unfamiliar to you, don't worry. In this article, we will decode this tech jargon and present it in a more simpler and more digestible manner. At its core, Tracert or Traceroute is a command line tool used to track and illustrate the path that data takes from one point to another. This command, known as Tracert in Windows and Traceroute in Linux, is a utility that helps you understand how data travels from your computer to its intended destination, be it a website, a network computer, or any remote system on the internet. Think of this journey like a trip you might make across the country. Your starting point is your local system and your destination is the remote system. Along the way, your data doesn't take a straight shot to the destination. Instead, it makes several stops at different routers, just as you might stop at several cities during your cross-country trip. Tracert is like the travel diary that records each city you visit during your trip. Let's get into the specifics. Tracert uses the Internet Control Message Protocol, that is ICMP, a supporting protocol that sends error messages when there are issues with the delivery of IP packets. It's much like a courier service sending you a notification when your package faces a delay or cannot be delivered. The tool sends a sequence of ICMP Type 8 echo requests which are very similar to the request sent by the ping command. What's unique here is that Tracert manipulates a property known as time to live (TTL) in the IP header of these requests. The TTL is like the expiry date on your packaged food. It tells the network how long the packet should be kept alive or how many routers it should pass through before it's considered stale and discarded. Tracert starts with a TTL of 1 for its first request. This means the packet will expire and be discarded after just one hop. The router that discards this packet will send an ICMP Type 11 time extended message back to the originating system. This message tells Tracert the address of the router, the first stop on the data's journey. Upon receiving this response, Tracert will then send out another wave of requests, this time with a TTL of 2. This allows the packet to reach the second router in the path before they expire and are discarded. The second router, like the first, sends back a message with its address. The process continues, with Tracert incrementing with the TTL by 1 for each new wave of requests, allowing it to discover the path one hop at a time. If you were to observe the output of the Tracert command, you would see a list of router IP addresses, each representing a stop on the journey your data takes. Additionally, Tracert performs a reverse DNS lookup on each IP address, which can often provide the domain name associated with the router's IP address. This additional information may give you a clearer picture of where your data has traveled. This journey is repeated until the data reaches its destination or until the number of hops reaches 30. Which is the default limit set by the Tracert command. Once the destination is reached, it sends back an ICMP Type 0 echo reply telling Tracert that the destination has been reached. This marks the end of the data's journey. To give you an example of how this works, imagine you are sitting in New York and you want to send a packet of data to a friend in San Francisco. You would initiate a Tracert command to your friend IP address and Tracert would then send out the first wave of request with a TTL of 1 reaching a router, say in Philadelphia. This router would discard the packet and send back a time-exceeded message. Tracert would then send the second wave of request with a TTL of 2, reaching the next router, perhaps in Chicago, which would again discard the packet and send back a message. This process would continue until the packet reached your friend in San Francisco. Using the Tracert command is quite easy. On a Windows computer, you would simply open the command prompt, type in Tracert followed by the IP address or the domain name of the remote system you are trying to reach. In Linux, you would open the terminal and type in Traceroute followed by the same information. You may find various options for using Tracert, which can be discovered using the Tracert-h command in Windows or man Traceroute in Linux. These options can allow you to change the maximum number of hops, specify the size of the packet sent, and more. Understanding Tracert and its function can be instrumental in diagnosing network problems, planning network paths, or simply satisfying your curiosity about how data gets from point A to point B on the vast landscape of the internet. By revealing the hidden network paths, Tracert gives you a window into a complex world of transmission of data, making the invisible visible. Thank you so much for watching this video. Do check out the written explanation on our website and don't forget to take this quiz based on this video. The links are in the description box below. Subscribe to our channel to watch more interesting videos. If you have any doubts, do let us know in the comment section and we'll try our best to solve them for you. For private coaching, do contact us by visiting shreelearningacademy.com or on WhatsApp. See you in the next one.